In the name of God. Praise be to God, Prophet Muhammad. We will continue with you a new lecture on current and voltage transformers. When a relay falsely trips, taking a line out of service without a fault, an investigation is needed. First, check the relay's current and voltage values. Then test the CT and VT to ensure their outputs to the relay are accurate. What are the tests for CT and VT? Let's start with the VT test. We'll discuss CT test later. To prevent it from happening again, when we conduct an investigation, the first thing we do is ensure that the internal current and voltage values to the relay are correct. This helps us determine whether the issue is with the relay itself or with the CT and VT. At that point, we need to perform tests on the CT and VT to ensure their integrity and confirm that the outputs from the CT and VT going into the relay are 100% accurate. VT test: insulation, winding resistance, ratio, polarity, primary, secondary injection, loop resistance, burden. Nation Renaissance, Food Renaissance. The VT tests include the insulation test, winding resistance test, ratio test, and polarity test. Let's begin with the insulation resistance test, known as the IR or Megger test. Megger is the company that made the device for testing insulation resistance, founded in 1889. A common question is if the device is named after the test or vice versa. An engineer at Megger explained Megger comes from mega ohm by removing A and adding Mega ohm measures insulation resistance. It is called insulation resistance test and is symbolized by the symbol IR test. It is also known as Megger test. The word Megger here is the name of the company that made the device that tests the insulation resistance. It was founded in 1889 and has many devices, including the relay tester, the circuit breaker tester, and the multimeter. Did the company name the device Megger after the test, or is the test named after the company? A Megger engineer explained that Megger comes from mega ohm. They took mega, removed A, and added The IR test is essential for electrical equipment. It's done for VT, CT, circuit breakers, bus bars, generators, and motors. It measures insulation resistance, ideally high to prevent leakage current. Leakage current means insulation is ineffective. It allows current through insulation, causing a short circuit. This is dangerous. Insulation resistance is in giga or tera ohms. Leakage current in milliamp. How is the IR test conducted? The IR test is crucial for electrical equipment. It measures high insulation resistance, prevent leakage current. Leakage indicates insulation failure, a dangerous short circuit, measured in gigatera ohms, leakage in milliamps. The IR test uses a Megger to apply DC voltage, 5 kV from primary to ground, 2.5 kV from primary to secondary, and 1 kV from secondary to ground. If leakage current occurs, it means that the presence of insulation and the absence of it are the same. The current will flow through the insulation from phase to phase or from phase to ground. This is one type of short circuit voltage, and it's very dangerous. The insulation must be very high, and insulation resistance is measured in giga ohms or tera ohms, while leakage current is measured in milliamps. Now, how is the IR test conducted? Apply 5 kV from primary to ground, 2.5 kV from primary to secondary, and 1 kV from secondary to ground, each for 1 minute. If 2 secondary windings exist, test each with 1 kV DC for 1 minute. Insulation resistance should be in giga or tera ohms. Per IEE 43, above 2 mega ohms is acceptable. We apply 5 kV DC to the primary ground, 2.5 kV to primary secondary, and 1 kV to secondary ground for a minute each. For secondary windings like metering and protection, test each with 1 kV DC for 1 minute. Insulation resistance is typically in giga or tera ohms. Per IEE 43, above 2 mega ohms is acceptable. One is for metering and the other for protection, for example. We test each winding by applying 1 kV DC for 1 minute. Typically, the insulation resistance value should be in giga ohms or tera ohms, and according to IEE 43 standards, the value is considered acceptable if the insulation resistance is above 2 mega ohms. It's important to note. Very significant point regarding this standard. Red to ground at 10 tera ohms is illogical if yellow is 9 tera ohms. And for example, if the yellow to ground is 9 tera ohms and the blue to ground is 5 mega ohms, and you tell me that this is an acceptable value, then common sense rejects this. We start the test by taking 2 cables from the Megger device, placing one on the red phase, for example, and the other on the ground. We press the push button for 3 seconds after setting the applied voltage and the test duration. It's important to set the applied voltage and test duration correctly. It's more advisable in general to ground the other phases. We are not typically testing usually. You should do it in such a way that you do it, so that you do it, so that you do it, so that you do it. It's preferable to ground the other phases that we are not testing. The revival of a nation.